Imagine, just for a moment, that you possess a magical key, one capable of unlocking the universe's most profound secrets. Through this tiny aperture, you peer into the cosmic forge, witnessing the universe in the very act of creating stars. Clouds of gas and dust swirled in a ballet orchestrated by gravity, their dance stretching across distances so vast that even light, the fastest traveler we know, would take thousands of years to cross them. This is not merely a flight of poetic imagination. Thanks to the relentless ingenuity of humankind and the marvel that is NASA's James Webb Space Telescope, we now stand at the threshold of cosmic understanding, gazing through the clearest window yet into one of nature's grandest mysteries, the birth of stars, and perhaps the origins of life itself. The telescope's latest landmark achievement? An image of the Cat's Paw Nebula so stunning, so detailed, that it is already transforming astrophysics and rewriting textbooks. But what do these luminous clouds, intricate filaments, and enigmatic shapes truly reveal? Why has the astronomy community erupted with excitement and awe over this cosmic spectacle? And what could these revelations ultimately mean for us, here on Earth, as we ponder our own place among the stars? Let us begin with the basics. The Cat's Paw Nebula, called NGC 6334 by scientists, and sometimes catalogued as Sharpless 2284, is nestled within the constellation Scorpius. It lies at a distance of about 5,500 light-years from Earth. So put that into perspective, if you set out today at the speed of light, the fastest speed known in physics, you would need more than 50 generations of human lives to reach this cosmic nursery. Its whimsical nickname comes from its appearance in photographs: large, rounded lobes that resemble the paw print of a giant cat. But beneath this playful image lies a stellar nursery of staggering scale, a vast celestial factory stretching more than 320 light-years across. That is more than 3 million trillion kilometers, an expanse so immense that even our own mighty sun would seem like a mere grain of sand within its boundaries. For decades, astronomers have gazed longingly at the Cat's Paw Nebula using some of the most powerful tools at their disposal, including the legendary Hubble Space Telescope. Yet even Hubble, with its remarkable capabilities, was unable to pierce the thick curtains of cosmic dust that enshroud the nebula's inner workings. Visible light, the kind our eyes detect, is easily scattered and blocked by dust particles, making it nearly impossible to see the nebula's true heart. It is here that the James Webb Space Telescope, often simply called Webb, has become a true game-changer. Launched in December of 2021 and becoming fully operational by July of 2022, Webb is now 3 years into its ambitious mission. Its advanced suite of instruments, especially the Near-Infrared Camera, or NIR-CAM, can penetrate the nebula's dusty veils, unveiling structures and processes that were once completely hidden from human eyes. As Dr. Klaus Pontoppidan of the Space Telescope Science Institute puts it, Webb's infrared capabilities provide an entirely new perspective on the universe. This is not just enthusiastic rhetoric. By collecting and analyzing near-infrared light wavelengths invisible to us but essential for probing cold, dense regions, Webb is revealing the mechanisms of star formation in detail that was once the stuff of science fiction. So, what has Webb uncovered within the Cat's Paw Nebula? The telescope zoomed in on the so-called toe beans, those compact, rounded regions of dense gas and dust, each teeming with embryonic stars. Within these knots, some stars are nearing the dramatic finale of their gestation, emitting fierce ultraviolet radiation and powerful stellar winds. These forces carve out voids and sculpt the surrounding material into luminous shapes, glowing in fiery red, golden yellow, and sapphire blue. The image is both a work of art and a scientific goldmine. The bright, reddish clumps highlight areas where massive stars are currently being born, while the elongated, dark filaments betray the presence of stellar embryos, stars so young that their nuclear fires have yet to ignite. But this is no static snapshot. The process of starbirth is a fleeting, tumultuous affair. As newborn stars begin to shine, their energy disrupts the fragile environment around them, blowing away the very clouds that nurtured them. Imagine trying to build a sandcastle in the midst of a hurricane. The forces of creation and destruction are locked in a relentless tug-of-war. Dr. Michelle Thaler, a leading astrophysicist at NASA, puts it succinctly: "The stunning images vividly demonstrate the fundamental laws of physics governing stellar formation. What we are witnessing are the universe's most basic rules: gravity, thermodynamics, and radiation, all battling and balancing to determine the fate of new suns. These discoveries, however, extend far beyond satisfying scientific curiosity. The insights gleaned from the Cat's Paw Nebula have profound implications for our broader understanding of the cosmos. Webb's observations are illuminating the complex interplay of forces that shape entire galaxies, from the mysterious pull of dark matter to the subtle chemistry that may one day give rise to life. By studying how newborn stars carve their surroundings, astronomers can refine their models of galaxy evolution, gaining new hints about the invisible scaffolding of dark matter that holds galaxies together. As an expert cited in Scientific American notes, the nebula's mass distribution could unlock clues about the enigmatic behavior of dark matter. Let us return to the core of the action: star formation. The Cat's Paw Nebula is classified as an emission nebula, meaning its gases glow with light thanks to intense radiation from nearby young stars. This radiation ionizes elements such as hydrogen and oxygen, causing them to emit light at specific wavelengths. By analyzing the spectrum of these emissions, astronomers reconstruct the nebula's chemical fingerprint, crucial for understanding the processes at play. One particularly intriguing region, known as the Opera House, features a nascent yellow star that is actively dispersing its cocoon of dust and gas, clearing a path for its emergence as a main sequence star. Such observations are not merely of academic interest. They are the building blocks for mapping the timeline of stellar evolution that has shaped our galaxy over billions of years. The Cat's Paw Nebula is also a unique laboratory for investigating the earliest stages of planet formation. Webb's razor-sharp vision allows astronomers to hunt for protoplanetary disks, the flattened, dusty rings surrounding young stars where planets are born. These disks are the cradles of future worlds, places where rocky planets like our Earth may eventually emerge. Dr. Jane Rigby of NASA highlights the importance of this research. JWST's unparalleled resolution enables in-depth studies of galaxy formation, but it's the details of planet birth that could soon change everything we know about habitability. Hidden within these disks may be the seeds of continents, oceans, and even the spark of life. The search for complex organic molecules within the Cat's Paw Nebula is equally thrilling. Organic molecules, combinations of carbon, hydrogen, oxygen, and nitrogen, are the fundamental building blocks of life as we know it. Webb's highly sensitive instruments can detect the unique spectral fingerprints of these molecules, raising the tantalizing idea that the ingredients for life are not unique to Earth, but scattered across the universe. Already, scientists have identified hints of such molecules nestled within the nebula's dusty folds. These are not random chemical stains. They may represent the first steps on the path from star to planet to living organism. But let us not overlook the challenges. Webb's mission is not infinite. The telescope relies on a finite supply of fuel to maintain its precise orientation in space. Most estimates suggest Webb could remain operational for at least 1 decade, possibly longer if engineers manage its resources carefully. This ticking clock creates intense competition among scientists worldwide, all vying for precious observation time. As Dr. Sean Domagal Goldman, acting director of NASA's Astrophysics Division, explains, Webb continues to deliver on its design, revealing previously hidden aspects of the universe, from the star formation process to some of the earliest galaxies. The pressure to prioritize the most promising targets is huge. Yet even within these constraints, every new discovery is rewriting the rules of cosmic evolution. Webb's findings are already guiding the next generation of space telescopes, such as the nearly complete Nancy Grace Roman Space Telescope and the upcoming Habitable Worlds Observatory, which will focus on finding Earth-like planets and probing the mysteries of dark matter. As an expert from Space.com observes, JWST's groundbreaking findings are poised to shape the trajectory of future exploratory missions. The impact of the Cat's Paw Nebula's revelations stretches far beyond the halls of academia. For dreamers, students, and everyday people here on Earth, these discoveries have practical significance. Understanding how stars and planets form is not just an abstract intellectual pursuit. It is directly connected to the question of our own origins. How did our sun come into being? What processes led to the birth of Earth and the emergence of life? Could the same chemistry that sparked life here be at work somewhere else in the universe? If Webb detects organic molecules in the nebula, molecules that, under the right conditions, could assemble into amino acids, proteins, or even simple cells, would bring us one step closer to answering the ultimate question: are we alone? This quest carries not just scientific, but also philosophical weight. The more we learn about cosmic nurseries like the Cat's Paw Nebula, the more we appreciate the delicate, interconnected web that binds matter, energy, and time together. The processes unfolding in a nebula, thousands of light years away, are, in a very real sense, connected to the atoms in our own bodies. Every element, heavier than hydrogen, carbon, oxygen, iron, was forged in the heart of a star, as Dr. Michelle Thaler eloquently puts it. The stunning images vividly demonstrate the fundamental laws of physics governing stellar formation. By studying these far-off cradles of creation, we gain insights that could one day help us protect our home planet, the only place we know that harbors life. Let us step back for a moment and consider the broader consequences. The Cat's Paw Nebula's turbulent environment serves as a microcosm of the universe's endless cycle of birth, death, and renewal. The intense radiation from massive young stars can both trigger and suppress further star formation, sculpting the landscape for generations of stars to come. The interplay between gravity, radiation, and chemistry determines which regions collapse to form new suns and which are blown away into interstellar space. Yet, despite all we have learned, so much remains mysterious. The process by which cold, diffuse clouds of gas collapse into dense, luminous stars is governed by a complex interplay of forces that astronomers are only beginning to understand. Webb's observations are helping refine theoretical models, but the nebula continues to raise new questions. How do magnetic fields shape star birth? What role does turbulence play in fragmenting clouds into clusters of stars and planets? And how does the presence of dark matter influence the structure and evolution of these cosmic nurseries? Experts from astronomy.com emphasize that JWST significantly enhances our ability to comprehend the complex life cycle of stars. This journey is about much more than cataloging stellar births. It is about deciphering the full journey from molecular cloud to mature solar system. Understanding this journey could eventually guide the search for habitable planets around other stars, and perhaps even inform the design of future interstellar missions. As Webb continues to observe the Cat's Paw and other star-forming regions, astronomers are already planning ambitious follow-up studies. They aim to search for more protoplanetary disks, precisely measure the distribution of dust and gas, and hunt for the spectral signatures of complex organic molecules. Each new image returned by Webb is like a page in a cosmic storybook, filled with mysteries waiting to be unraveled by future generations. Let us delve deeper into the nebula's significance in the broader context of galactic evolution. The Cat's Paw Nebula is only one of countless star-forming regions scattered across our Milky Way and other galaxies. Each of these nurseries serves as a crucible for new generations of stars, continually enriching the interstellar medium with heavier elements and complex molecules. Over billions of years, this process has transformed the universe from a simple expanse of hydrogen and helium into a rich, dynamic tapestry teeming with the ingredients necessary for life. Historical parallels abound. Consider the Orion Nebula, another famous stellar nursery that has long been a target for astronomers. Like the Cat's Paw, it is a chaotic region where massive young stars are sculpting their environment, even as they emerge from it. The difference now is that Webb's infrared eyes allow us to see deeper, with greater clarity than ever before. This leap in observational power can be compared to the revolution that occurred when Galileo first pointed his telescope at the night sky, revealing moons around Jupiter and mountains on the moon. Just as those discoveries shattered old worldviews, so too is Webb shattering our understanding of cosmic genesis. The Cat's Paw Nebula's role as a natural laboratory extends to the study of stellar feedback, the process by which newly formed stars influence their surroundings. Massive stars, through their fierce radiation and powerful winds, can trigger new waves of star formation or halt it altogether. This feedback loop is essential for regulating the growth of galaxies and determining their ultimate fate. Webb's data is refining our understanding of how these processes operate on both small and grand scales. The nebula's vivid colors and evocative structures are not just beautiful, they are encoded with information about the temperatures, densities, and compositions of the gases within. For example, the fiery red clumps scattered among the brown dustmark regions where massive star formation is underway, while the blue-white stars in the lower left of the nebula appear sharp and clear because the intervening material has been blown away by stellar radiation. The bright red-orange oval at the top right of Webb's image is especially eye-catching. It is likely a dense area just beginning its own star formation process, evidenced by the relatively low count of background stars visible through it. As we look ahead, The discoveries made in the Cat's Paw Nebula will shape the priorities and strategies of future missions. The upcoming Nancy Grace Roman Space Telescope will expand our ability to search for exoplanets and dark matter, while the Habitable Worlds Observatory will zero in on Earth-like planets and the conditions necessary for life. Each new telescope will build on the foundation laid by Webb, pushing our understanding ever further. One of the most exciting prospects is the potential detection of biosignatures, chemical signs of life, on distant worlds. By studying the environments where stars and planets are born, we can better predict where to look for life beyond our solar system. Webb's discoveries in the Cat's Paw Nebula may one day help us answer the age-old question: are we alone in the universe, or is life a common outcome of cosmic evolution? There are also practical lessons to be drawn from these cosmic explorations. The same physical principles that govern star formation, gravity, thermodynamics, radiation, apply across the universe, from the smallest planetary systems to the largest clusters of galaxies. By studying these principles in action, scientists develop tools and models that have applications beyond astronomy, influencing fields as diverse as climate science, materials, engineering, and even medicine. Let us not forget the human element. The story of the James Webb Space Telescope is itself a testament to international cooperation and perseverance. Built and managed by NASA, with contributions from the European Space Agency and the Canadian Space Agency, Webb is the product of decades of collaboration and innovation. Its very existence is a reminder that, when united by curiosity and vision, humanity can achieve the seemingly impossible, sending a billion-dollar observatory a million miles from Earth to unlock the secrets of creation. So, are we truly closer to unlocking the universe's greatest mysteries? Absolutely. Thanks to Webb's near-infrared vision, we are not merely gazing at distant, beautiful images. We are bearing witness to the raw, chaotic, and astonishingly beautiful forces that have shaped every planet, every star, every atom we have ever known. The Cat's Paw Nebula stands as a testament to human curiosity and ingenuity, a cosmic wonder that is rewriting our understanding of the universe in real time. And here's a secret that even many astronomy enthusiasts may not realize. Nestled within the nebula's dustiest regions, Webb has already detected signs of molecules that could one day be found on living worlds. These are not mere chemical smudges, but potential precursors to the chemistry of life itself, hinting that the seeds of biology may be sown far beyond our own solar system. If you found this journey into the cosmic cradle as awe-inspiring as we did, be sure to subscribe for more stories from the frontiers of science and technology. Share your thoughts in the comments below. Could the secrets of our existence really be drifting in a nebula thousands of light years away? The universe is far more mysterious and wondrous than we ever imagined, and together, we will keep chasing its secrets.